Good morning, everybody. I'm William Ray, but he calls me Billy. I'm the Senior Product Manager at AirBorn. Been at AirBorn going on 18 years now. Did a little bit of everything within AirBorn between production, QA, machine shop, application engineering was where I spent most of my time, and now as a product manager. But in the last probably couple of years, I've been hearing more and more about rugged interconnect, and really, what does that mean? What does it mean to be rugged? And I know that the term rugged is very subjective. You can look at these two images, and I can show half my buddies the picture of the Jeep, and they're like, yeah, that's a rugged vehicle, right? You can take it off-roading, you could go, through the mud, whatever you want to do. But when I think of a rugged vehicle, I think more of the Humvee. So, and I'm sitting there, I'm working on this presentation. Again, we're still a little bit in the COVID time, so I'm working at home, and I yell out to the wife, and I say, what around the house do you think is a rugged connector? Like, when you think about connect, she said, well, an extension cord. And I thought, wow, that's kind of pretty quick. I didn't expect her to come off with that, and I thought about it, and I said, well, I guess extension cord's a pretty good answer. It's in a lot of harsh environments. It connects a lot of different things, handles a lot of different power options, and I said, well, what about all these iPhone cords we use around here? And I mean, right away, it was like, absolutely not. I've got a 5-year-old son, and I think we go through those about one a week, those cords for the iPad. So if you could subscribe to the iPhone cord on Amazon, we probably would. So I think the justice is really that it's subjective, right? It's somebody's opinion. It's what we call rugged. And I think today I'm really going to try to show you what AirBorn's been known for rugged interconnects for the over 65 years we've been in business. Take a look at rugged. I'm going to take this back a little bit. We've been talking a lot about system level. We're going to get down to the nuts and bolts of the connectors. And I think it's important sometime to even think back to the contact system and how it all kind of starts. So we're going to look at the contact. We're going to look at design features, different materials that go into rugged interconnects, and then kind of what we're doing to develop new interconnects in the future. The customers we've been talking to, I've heard swap C several times today. And then what industry applications are we really targeting some of these newer developments? Kind of see on the right, we're definitely not a card edge guy, so we're stamped and formed. You can see all of our contacts throughout the years that we've developed. Different styles, but all stamped and formed, what we deem as a rugged style interconnect. So kind of taking it all the way back to raw materials. We look at what materials we want to use in that contact system for a couple different things, for either electrical conductivity, thermal conductivity. Can you stamp and form it? Can you machine it? And then, what does it cost? Most of our contacts today are beryllium copper. Beryllium copper is still probably one of the most used materials in interconnect contacts, but it's used for its high yield strength, its high hardness. You can form it stays formed, and then it doesn't really fatigue under stress. But on the phos bronze side, or on the pin side, the non-active portion of the contact, we use a lot of phos bronze. It's got a real high yield strength. Yeah. So we've got a contact material. Now we look at the plating, and really I think that this is probably one of the more subjective terms to rugged interconnects is the amount of gold to put on the contact. Now, 30, may work for a lot of applications. I think when we start talking to our customers, it's always AirBorn's known for 50 microinches of gold. And not only that 50 microinches of gold, but the nickel plating we put underneath it to keep that gold from migrating up through the copper, so you've got a real good electrical connection all the way through. So you got a contact, you got it stamped and formed, you got it machined, you got it plated. We start looking at the wipe. So I'm sure everybody's familiar with the wipe of the contact as the pin mates within the socket, but at a minimum at AirBorn, our kind of golden rule is no less than 1.5 times the pin diameter. So what that does, it removes any oxidation on the pin during the mating process to keep the resistance values down, and it also provides any kind of mating tolerance from thermal expansion, from the application expansion, whether the boxes or any fixturing that may be in there. But as we looked at all of our wipe and our products, we're usually 3 to 5 times the pin diameter. So the 1.5 is definitely a minimum. So we've got a contact, but really what really makes up that contact? There's all kind of features, and again, these next slide will kind of show a little bit better, but there's there's so many aspects of a contact that can make it either a high-speed product, high power, high mating cycles. So we look at all the different termination tails we have to design in that contact. How does that affect it for being automated or stitched during the manufacturing process? Keeping that normal force on multiple points of contact. I think that's probably one of the biggest things that we tout ourselves on at AirBorn, is that it's not two points, it's usually 3 or better, in most cases 4. And then also keeping the stress levels down on that contact so you can get that high durability out of it. So I started, when I first started AirBorn, I did some CAD, not a whole lot, but it was mostly you see the contact on the screen, it looks huge, and we started actually a project that I'm working on, we started stamping the contacts out, and I couldn't believe how much smaller it was. I get the idea of the size comparison, but it's definitely something we had to put in perspective on the overall size that we're seeing the market going, standard paperclip. But there's so much that goes into a contact when you're developing it. It's not just stamping it out, popping it in the connector. Every little feature has to be scrutinized. So really, we have a saying that rugged always starts with a contact, and I think probably a lot of people say that. I don't think we made that up, but you gotta protect that contact. That's one of the things that we really try to do, is put as many things around that contact to protect it. And for our space military applications that we're primarily in, commercial air, they've got nickel-plated shells. There's LCP and PPS molded insulators. They're epoxy sealed in the back so you don't get FOD migrating down during the processing of it, or even during in its environment. But one big thing we're hearing more and more, especially for space applications, it's not the connector as a whole anymore that has to meet the NASA outgassing. It's every single component in that system. So we're constantly testing and retesting and evaluating and for outgassing. So I think in the last VITA meeting I was at, we were talking about more and more about board real estate and how outboard hardware is consuming more and more of that precious real estate on the PCB. So if you look at a lot of the AirBorn's interconnects, our hardware is not only for mating the connector, the half turn kind of a deal, or even the locking or guide, we've got both. But it also allows you to mount that connector onto the PCB. So if you look at the collar, this is the cross-section view of the connector. The collar actually allows you to screw a number 4 nut down on the bottom. Oh, and it's one point there too is it's field repairable. So you can take that hardware out, swap it out, which is, you'd think you make something rugged, but somebody finds a way to break it or damage it and needs to be replaced. But so we got the contact made. It's in a body, but now how do those two connectors intermate with each other? What is the sequence? And we try to add as many features around the connector to protect that contact during that engagement area. So next few slides, I'll kind of progressively go through them, but it shows the mating sequence that we kind of follow with majority of our connectors. The hardware always engages. It's kind of the first alignment feature as it goes in before into the insulator. This is pretty common for most connectors, but the metal shells engage. If you look at the hardware and the shells, we try to put as many chamfered features to kind of pull and align everything in as they come together. Then the contact engages. It's got a round tip into a spherical hole inside the insulator. And then the HD pins engage the socket. So now after all these features have come together, we're just now starting to get to where the contacts are starting to engage. On the right, in this particular example, that's an SMPM RF. Very similar, where it's engaging the insulator first, and then it's going to go down and start mating with the ground plane on that. The HD pins start their wiping action, which is about 78 thousandths in this particular instance. The RF contacts engage, the ground contacts start to wipe, the signals wipe, and then it's fully mated when the shells are completely bottomed out. One thing that we're seeing more and more requests for in the market is really to seal these connectors up while they're mated. Now, this isn't an IP-rated seal, this is an environmental seal. If you guys are familiar with micro-Ds, they do a very similar sealing action with a fluorosilicon gasket. It really keeps all the dust, debris, moisture out of that interface. Again, we're just trying to protect that contact. One thing as I'm learning in VITA, I'm a newbie as well, is all the alignment features that go into the backplane connectors. It's really impressive how we got some of the mating sequences within those products, but we do very similar things within our connectors as well, where we look at half the size of the guide pin, where it's 30 thousandths kind of left and right, or whatever the size of the guide pin is, but also trying to look at if you were to tilt or cock this thing over, how does it actually align, and does it protect the contacts prior to engagement? But even more so, if somebody grabs out in the field, grabs our connector and turns it around backwards, will it mate? Can you mismate it? And we try to add as many features as we can by keying it, adding lobes. The hardware can be keyed as well, but really trying to protect that contact. So like I said, we started about 2 years ago, right when COVID started, and one part of my role is to develop new products. And we called about, I don't know, 100 plus of our customers, whether through Zoom, a few shows every now and then when I could, a few in-persons, coffee shops, wherever we could do a VOC at. And really what we saw that the market still wanted was a lot of things we've been doing for the last 65 years, and that's that multiple points of contacts, 50 microinches of gold. But the theme I put on there, smaller doesn't mean less. I think that kind of rang true in a lot of the presentations I heard today, where customers aren't just wanting a smaller connector. Well, they want it to perform more than what they were already getting. They want higher speeds, more power in a smaller, compact area. So, but also kind of keeping that ruggedized, I guess all the ruggedized features that AirBorn has been known for. So we looked at developing a new contact. That contact to be designed for 4 points of contact and multiple axis, where they're X and Y, keeping that one-piece design where there's no cut or crimps or welds. A class 3 surface mount. I think that's probably more and more prominent now with the surface mount J-leads, but also keeping it where the mating forces are relatively low, but also keeping them low or high enough so that you don't have that contact resistance as the contacts mate to remove that oxidation on there. Stamped and formed, that's probably one of our biggest things that we're doing now. More and more stamped and formed contacts, reduces cost, automated assembly. But while you're doing all this, you're trying to optimize it for the impedance and SI. So we have customers still running very low speed LVDS type signals, but we're getting more and more requests where it's not just Zowie speeds anymore. It's, we're getting 25 gigs. That's kind of what's coming per lane. So it's funny, I think Bob was talking about Cubesats in his presentation, and I was like, man, I'm glad I had this image in mind already. So I know this isn't a traditional Cubesat stack up here, but this really shows that we're trying to develop more and more products where that it's not just inside the box, but it'll get you from box to box, and you can do board to board, motherboard daughter card, mezzanine, flex jumpers, kind of the whole gamut within one single product line, and that's what our customers are looking for. This particular instance shows even RF, discrete, twin ax. There's a power module in here as well. So to kind of wrap things up, I probably went through this pretty quick, but we hear the term rugged and rugged interconnects and how subjective that term is all the time, and I think we can all argue different points, but at AirBorn, we talk about it always starts with a contact, keeping that multiple points of contact, 50 microinches of gold, keeping the metal shell around that body to keep it protected, all the materials, alignment features like I showed in the mating sequence, and then that swap seat mentality. But we kind of played on the A and the P, where it's the A is not for and, it's for availability and performance and not power, because we're seeing more and more signal types wanting to be ran through one interface. So I appreciate everybody's time today. That's kind of the wrap up there, Jerry. Is there any questions or?